Hello friends, now we will see our next application and that is nothing but the summing amplifier. Here you can see the Opamp is already connected to the positive negative VCC and now the summing amplifier is nothing but this type of Opamp circuit will actually used to combine the number of voltages present on two or more inputs. Okay, so here what we will do is we are giving voltages to the positive and we are giving positive feedback over here. So here what I'll do is I'll connect one battery and then it is another and this is the third one. Okay, so what I'll do here is I'll give the battery name as V in 1 and the voltage of this battery will be 3 volt. Another battery will be V in 2 and the voltage of this battery will be 5 volt. The third one I'll use as a 1.5 volt and this is my V in 3. Okay, so here I'm connecting ground to all three of them. The resistors that are in series will connect between these batteries and our terminal. Okay, so here I'm just rotating the resistor and connecting that resistor with the battery. This resistor will nothing but the 1 kilo ohm. We don't need 10k here. And the same I'll repeat. You can skip the video. Here I'm shorting all the pins of the register. R2 again will be the 1k and R1 as well will be the 1k. This is how I gave the three different inputs to the single pin of Opamp. Okay, now what I need to do is I need to take one resistor and that resistor I will place between the positive pin and the negative output. So here is the output at pin number 6 and this is my voltage, that is RF, and this volt is nothing but the 1k only, RF, that's it. Now everything is done. I'll just take the ground and give that ground to the pin number 2 directly. Okay, so everything is there at a positive side. I'll connect one resistor here and that resistor I'll just rotate it and the value of resistor will be 10k because it is nothing but the RL. Okay, so just change the value to 10 and the name of resistor as RL. Okay, so across the RL, as you all know, I need to connect one voltage voltmeter. Why? Because I need to check the voltage only across the RL, otherwise I'll not get any kind of waveform here. That's it. Everything is done very properly. Now I'll check the analysis here in a transient. What I'll do is I'll go for this. Now you can see my voltage is, if I want to see the separate curves, I cannot because I'm able to only see this voltage. So what I'll do here at a meter, I have 1, 2 and 3. Okay. So all I'll take and I'll do the analysis as a transient. Okay. So here you can see now there are some errors. Okay, so what errors? I need to find out that errors. VF4. Okay, so this is by mistake. It is connected. Okay, so there is nothing to worry. Now just go and check the transient for whatever time you want to check. Just see the separate curves. Here you can see this is your first channel which is at approximately the value is, you can see over here, and the output will be here, that is nothing but the addition of all. Okay, so why all the voltages are you are looking is same? Because we have connected this in such a way that our voltage you can take in a series. Now if we just change quite here, so what it actually do is, what I'll do, I'll just connect this wire and give that to the pin number 2. That's it. Okay. So here my VF3, I'll keep that as it is. Okay. Let's see now the transient. This is the transient. If you check that with the separate curves, yes, you can see the same, and the output is what you are able to see is nothing but the addition of all. It should be 6.5 volt. So this is how our this is how our summing amplifier will work. Hope you learned something new, and for more videos do subscribe the channel and like the video, press the bell icon to get the notification. Thank you.